Next up, we'll talk about empathetic code management and what that means. Jack Johnson sings this song about it's always better when we're together. I apologize for that. I shouldn't be singing. But I don't think it's always better when we're together, especially when it comes to infrastructure code and project code. Usually what you end up happening is you have like template code that serves your core HTML website. And then maybe some, like I mentioned, this infrastructure JavaScript code base using Angular or using React, something like that, and somebody needs to help her maintain it. And you have that living right next to your project code, your actual app code, because it's a small project. You don't want to have to maintain the overhead of two separate code repos. But that works when projects are really small, and it works really well when they're small, but it doesn't scale up. And I'll show you an example in a minute, but basically what we're faced with is we have longer release cycles because you have to regression test everything. When you change anything in the infrastructure code, that affects all of your application. You have to regression test all of your application. Responsibility becomes vague. Who fixes the bugs in the infrastructure code if you have 3 teams and none of the teams is directly responsible for infrastructure code? And then what happens if team A breaks team B's code with an update? Like, whose responsibility is it to fix that? Especially if team B's code was kind of wrong and they kind of did it the wrong way and team A just did something that should have worked technically. Who fixes that? It gets kind of messy there, and that ends up bringing in a lot of politics, and we don't want to get involved with that. It's better if I actually explain an actual story of this. So again, we have the app. And with our app, we have our site template, our reusable components, our common styles. All of this is called infrastructure code. And we have it living with the actual app code itself. And you have this team called the Start team, and they have their own part of the app that they own. And then you have the Lannisters, who also have part of the app that they own. And then you have the Targaryen doors, who also have their own part of the app that they own. And they have a whole bunch of others who are neat to kind of follow along with. They add a little bit to the story, but they're really not that important. What we're going to focus on is the Starks and the Lannisters, because they're the fun ones. The Stark team has been working like 3 weeks on this new feature that they're really excited to release. They have some common code that they expect to behave a specific way, but it's behaved that way for the past year. So, hey, what's going to change? They're about a day away from releasing. They've gone through a bunch of testing and validation that their product works. But the day before, the Lannisters, they released their code, and it kind of modified that code that Team Stark was expecting to work a specific way. And it doesn't really work that way anymore. But they needed to do this for their own release that they just shipped and is in production now. So they didn't tell the Stark team, because why tell the Stark team? They have no idea what the Stark team is doing, and why should they know? They're their own separate entity, so it's kind of a mess there. Well, the Stark team, they go to ship their code, and they realize that, oh my god, it's broken, and they're in scramble mode, and they hadn't told the Lannisters about their work. Again, why would these teams need to tell each other about their work? And I mean that seriously, because if every team is telling every other team about their work, it's just constant back and forth, and nobody's going to get anything done, because you're in meetings about, hey, I changed this, and hey, I changed this, and I guess at a certain point, nobody's changing anything, and then you have no problems telling each other about your work because you're not working on anything. Anyway, these teams are basically in panic mode. Well, the Starks are in panic mode. The Lannisters are like, hey, I already shipped my code, so yeah, I can't, it's out there, it's in production, and we need this release to go out because we have this hard deadline. So I guess put a pot of coffee on, because you're going to be working the weekend to get your project over the deadline. And then, you have your king kind of come in and say, you know what we need? We need a tiger team to discuss this, and we'll talk about it 8 a.m. Monday morning after you work the weekend to get it fixed. Who's been there before? I know I have. So with this, all of this could have been avoided by separating your infrastructure from your app codebase. There are 2 parts to this. One was that nobody was responsible for infrastructure code, and nobody was responsible for communicating that out. There wasn't a single person or a single team responsible for that. So people kind of make their updates as they need to and kind of hope for the best. Again, that may work when you're small, but when you're growing a team, it doesn't scale up. And then finally, and then the other part of that is that your infrastructure code was being pushed out to teams. So a team had to accept those changes, whether they wanted them or not. The Start team had to accept these new updates, even though they really would have preferred the old code to behave the way that it used to. So that's where I come to the idea of you want a separate team managing your infrastructure at a certain point, at a certain scale of your project. And you also want a separate code base for that infrastructure. And that'll look kind of like this. You have common JavaScript that is got your CSS, or you have common code, that's your CSS, your JavaScript, your images, all of that kind of stuff. And you have that in a common code base. And that's great. You have a separate team managing it, you have it in a separate code base, but you're not quite there yet. Because what you have here is when the king makes updates to their common code base, they push those updates immediately out to the apps. Because hey, they're new features and they're bug fixes, and who wouldn't want those right away? You want to get those features out. But if you're if you're changing code under people's feet, then you are going to be breaking production, because people won't be expecting it. And when you're changing little things here and there, as people are off in their world building their features, it's basically a recipe for disaster. And open source has figured this out. They had a post, jQuery team had a post saying, don't use the latest from jQuery. It's a bad idea. This will break your site. This will break production if you're using the latest, because we push out the latest and we don't test against your site, because we can't test against everybody's site. We can do our tests and we can hope that we don't break stuff, but we don't have the time to do all of that. So the opposite of this versus pushing your updates out to teams, you want to allow the teams to pull your updates down. So basically you make your updates, you bundle it up, and you say, here is this new update. When you're ready for it, pull it down and use it. And it's not an uncommon model to follow. In fact, a lot of open source projects follow it out there. jQuery being one of them, where they release their code out to a staging center or a staging area, and then teams come in and they come in and they say, okay, I want this version of jQuery for my site. And that's what they do. Or they can use jQuery latest and break their site. Now, to give you an example of what this looks like, you have the Start team, the app A. When they're ready to do their upgrade, they go to the common code base and they say, I'd like your latest, please. And they pull it down and they do their work and they do their release. And app B, meanwhile, is working with the version that they have of the common infrastructure. And then after they finish their feature, they say, now would be a good time to upgrade. So they come in and they get the latest and they do their regression testing and all that. All of this is on their own time, and app A has their version that they have off in their own land. Package managers follow this model a lot, like NPM. And you, as long as you're not using the latest flag, which you shouldn't be using, it won't do the upgrade to the newer version until you specifically ask for it. This brings along with it a lower risk of breaking production with a release, because teams have the time allocated to make their upgrade. That means no working on the weekends, usually. They can test their changes with small pilot groups, so they don't have to force this update on everybody. They can slice off a certain section and say, okay, you're going to get this newer version of the infrastructure code while everybody else gets the previous version that we know works. We can kind of take it piecemeal. And then if something does break due to a release, you can always wait to release it and say, oh, well, I guess we're not ready to upgrade this. And I guess this infrastructure change broke something that they didn't know that was going to break, but that's okay because it's not out in production. So we can take our time and wait to upgrade. And then finally, you can roll back an update because your infrastructure is versioned. And we'll get to versioning in just a minute. And all of this leads to, while it takes longer for your code to get out there from infrastructure to the applications, it's overall a faster process because you're on an infrastructure team, you have smaller testing efforts. You don't have to test every single application every single time you make a change. You let the teams handle that, and you follow your testing guidelines that you set up that are hopefully really good. But you don't have to worry about figuring out what app A does and what app B does and go through all of that mess and getting all the teams to release at the same time and all of that. And so all of this helps reduce the amount of overhead that you have to do with any sort of release. You can push stuff up there and not have to worry about it too much. As I mentioned, it does have the drawback that it does take longer for code to get out there from infrastructure compared to just automatically pushing it out there. That's a drawback, but it's a trade-off, and I think it's a fair trade-off and something that you just kind of accept that, hey, this is going to take a little bit more work, or not really a little bit more work. This is going to take a little bit more time to get through, but it saves us so many painful hours of breaking production. The other issue that you face with this, which is a bit harder to accept, is that this can lead to visual inconsistencies, especially if your infrastructure code includes visual design. If you make a change to how buttons look and half the teams out there upgrade to the new look and the other half are still waiting to upgrade, then a user who comes to the site and is expecting all the buttons to look the same won't get them to be the same. They're going to go from one app to another, or one section of the website to another section of the website, and they're going to be visually off. However, I don't think there's a great solution to this, even if you were pushing your code out, because you're trading that visual inconsistency for breaking production. And I think it's better to have a visual inconsistency than it is to completely break all the functionality of your website. But there are ways that you can get around this. You can plan ahead by bundling your visual changes. So if you know that you have a series of visual updates that need to be consistent across your site, then put the plan forward that you're going to work with all the teams to release all at the same time. It means that it's going to take a little bit longer to release because you have to work with everybody's timeline, but you will avoid the issue of the visual inconsistencies. So, take that little bit of extra effort that you normally don't have to take with a release of your infrastructure code, make sure all the teams are lined up, and coordinate that release. And that won't happen too often because hopefully you're not making huge visual changes all the time. You're able to make them more rare. Okay, that's enough about the push versus pull model. Let's talk about passively communicating changes, because it's a lot nicer to give information passively, as in, I'm going to kind of slide this under your door, and whenever you wake up, you can read it like they do at hotels. That would be very rude for somebody at 3 a.m. in the morning to bang on your door and say, here's your receipt, come take your receipt. It's a lot nicer to passively push the receipt under the door and let it be there for when the person is ready to wake up on their own time. It's the same way with project management. You want to give your information passively versus spamming inboxes or setting up endless recurring meetings of status updates that nobody's going to pay attention to and they're going to forget when the time is important, all that sort of stuff. So how do we passively communicate project updates? Well, one way is with versioning. I mentioned versioning before, and how if we have this model of pulling down updates, and we're going to have versions for our code. So there are many ways that we can do versioning, including the Microsoft way, which is to just make things up as you go along. Sometimes you use decimals, sometimes you go by the year, sometimes you use letters, and sometimes you skip from 8 to 10 just because 9 has some weird backwards compatibility issues. That's the theory, at least. Anyway, the idea here is that as a consumer of Windows, if I hadn't been paying attention to what Windows is, which obviously nobody out there isn't paying attention to it, if I were to be told, hey, I'm going to upgrade you from XP to Vista, what does that mean to you? Or if I were to ask you, which came first, XP or ME? You would have no idea if you didn't know the backstory of Windows. Those versions mean nothing to from a semantic standpoint. So speaking of semantics, there's this idea of semantic versioning. And semantic versioning is a way of defining these numbers that go along with your version. So you have a major number, a minor version, and a patch number. So the major version is when you make incompatible API changes. Angular is facing this. They're going from 1.3 to 2.0, and it's a complete overhaul, or mostly a complete overhaul, of how their API works, how their code works. And so that's a major change. Then there's minor versions where it might break some backwards compatibility, but it's not, weeks worth of effort. And then finally, you have this patch version, which is I'm making a bug fix here or there. I'm adding a new feature that hadn't existed before, and it's not going to break backwards compatibility. Cross your fingers that it won't. That's why you have many versions. But to the best of your knowledge, it's not going to break stuff. So what's that look like? Well, here we have a Node version that's going from 0.10.35 to 0.10.36. This is a patch update. So as a consumer of that, I can kind of trust that it's going to work. I do a little bit of verification to make sure that changes didn't break things. But when I'm planning out this upgrade, I can say, yeah, this will probably take 10 minutes just to do the regression on it and double check. But I'm probably not going to have to make any updates to my code itself. Compared to a larger change, a minor change from 0.10.36 to 0.12.0, I can kind of say, hey, this might take a little bit of work on my end. When I try to run this code, it's probably not going to work. So I probably should commit like a day to it, compared to going from 0.10 to 1.0, where I kind of have to commit a week to it or 2 weeks to it to kind of figure out, okay, they made a lot of changes. So let's double check and make sure that all the work that they didn't break our existing functionality. If you do want to learn more about semantic versioning, semver.org is just a great website for it. And there's a few counter arguments to this, and I think it's worth reading about. But I think you kind of have to accept that it's not a perfect model, but I don't think a perfect model can exist. And this is a really good model for versioning your code. Next up is the Node Stability Index. And this is a really cool idea that the Node.js... This is a really cool idea that Node.js put out there, that they had all these components that they knew some of them were farther along than others. And so they wanted this way to say, not all of this code is brand new. Some of it's pretty stable. How do we define that when a user comes to the site and they want to say, hey, I want to use the HTTP module. Is that a good module to use, or should I not use that? And then this also allows you to introduce new components with a disclaimer kind of saying, hey, this is a brand new component. You might not want to use it right now while we're kind of figuring things out. So they add this index, which can be 0 through 5, to all of their components. And they're going to say whether they're deprecated, so that means that they're going away eventually. Experimental, which is like brand new. Unstable, so it's not brand new, but it's definitely not had all, it's not reached maturity yet. Then stable, where, this has been tested, this has been battle proven, that sort of thing. API frozen, where it's basically more effort to break it than it is just to write a new component. So you want to freeze things down. And then locked, which is like, this is never going to change ever. So this, again, adds a lot of flexibility to your code base and helps people when they go to your documentation and they look at the accordion component and they say, oh, that accordion component, that's stable. So I can use that pretty easily and I don't have to worry about that. Compared to a team that may be on a tight deadline and they see, oh, this is an experimental component, I probably don't want to use that because chances are it's going to have a bug and it may get updated a day after we release our code, and then we have to figure out how to manage that a month down the line kind of thing. So I want to look at mainly the stable ones. The key with this is you want to update these indexes regularly, and you want to include the documentation along with the code. So if you have like a README file for all of your components, then include it right there. And make sure that once a month or so, all you have to do is just go through each of your components and say, okay, this one needs to be upgraded from a 2 to a 3, or this needs to be deprecated, that sort of thing. So that's the idea there. Another way to passively communicate is to keep a changelog. There's a great website, keepachangelog.com, that goes into why it's important to keep a changelog and why it's important to have that instead of these project status meetings that are basically a changelog but disappear as soon as that project status meeting is gone. Or you get those emails of, hey, we made this list of updates. Go ahead and save that in your magic folder that appears as soon as you think of, oh, what was that email that got sent out a month ago about changes to the project. I really wish I could find that. What are the words? How do I search for this? Instead of having that, they can go to the main root of your site and see changelog.md, a markdown file that has all of your changelog information in it. And they can say, okay, I'm upgrading from 1.3.1 to 1.4.5. What are all the changes that have happened since then? So that's what a changelog is. And the idea is that it makes it easier for users and contributors to see what important changes have happened between each release. And it can also highlight breaking changes. Now, you can do this manually, but for me, anytime I try to do anything manually, especially regarding documentation, chances are it won't get done. So the Angular team came up with a commit message format that I don't think is perfect, but I think provides a really nice structure for building out change logs with every release. So they have the following structure. They do the type of change that is occurring. So this can be a change like adding a new feature. You can say it's a style change. You can say it's a test change. You can say it's a documentation change. You can say it's a fix. And then the component that they're changing. And then along with that, the description of their change. So to give you an example, that looks like a feature change to the ruler component, and it's a new feature where we add inches as well as centimeters. There's also breaking changes for a fix that says, hey, I have this pen component and I want it to use blue ink instead of red ink. And this is a breaking change. So these are the important details that you need to know in order to upgrade your component. And then when you do a release, you have a script come through and build this changelog for you that includes the bug fixes and formats it really nice for you and includes the version number and when it was released and all of that. So all you have to do is search for changelog generator and you'll get a couple of good examples. GitHub changelog generator, conventional changelog, all of those can help you with generating changelogs.